Hello and welcome to 4.2, which is slope and direct variation. Sorry, my title slide wasn't working, so you have to deal with that right there. So we're going to talk about the relationship between slope and direct variation. So direct variation is an equation of the form y equals kx, which we've been talking about. And if you remember back when we were talking about proportions, and we had the equation P equals RB, and so it's similar, but what you need to know is that K is a constant of variation. Okay, and you know what else we've called K. So for these two graphs, we want to name the constant of variation for each equation. So looking at the equation, what's K? This side, K is 2, and this one, K is -4. Alright, so we're getting that from our equation y equals kx. Then the next thing we want to do is find the slope of the line that passes through each pair of points. So if you're looking at these 2 points, remember that we can count the slope using rise over run. So I would want, personally, I always start at the left point. So I'm going to start at this point right here, and you're going to rise 2 and run 1. So our slope then is going to be 2 over 1, which is just 2. So from the other one, I would start here, and you're going to rise 1, 2, 3. You're going to rise a -4, and so remember, if you're going down, it's negative, and you're going to run a +1 or -4. And so then notice your constant of variation and your slope are the same thing. So that's their relationship. So was 0, 0 a solution to the last 2 equations? So if you think back, was 0, 0 one of the points on both of the lines? Yes, it was. And so if we answer the question, what does it mean to be a solution? It means to be a point on the line, and that's very important to know. Okay, so a solution is a point on the line. And so in this case, it can be any point on the line. Okay, so what does having 0, 0 as a solution mean for the graph? That it goes through the origin. And we've talked about that we only have y equals kx, there's no plus or minus anything if it goes through the origin. So we want to graph the equation y equals x, and this is the most basic equation we can have that has a slope. And so here I have 5 steps for graphing any line, and you might want to jot them down. The first thing is to know what your slope is as a ratio. So what is our slope of this line? Well, our slope is 1 because it's y equals 1x, and so then our ratio would be 1 over 1. And make sure that makes sense because you're going to see that a lot. So there's no plus or minus anything here, so it goes through the origin. So we're going to start at 0, 0, or as close to 0, 0 as you can get a point, hopefully on 0, 0. Okay, and our slope tells us to go up 1 over 1. So from the point 0, 0, we're going to count the rise and the run. So there's up 1 over 1, and we're going to do it again, up 1 over 1 again. Okay, for a grand total of at least 3 points, and you're welcome to keep doing that as long as you want. And then you're going to draw a straight line through those with arrows on the ends. Alright, so here we have another example, and again, there's no plus or minus anything, so where do we start? We start at 0, 0, and then what does our slope tell us to do? Our slope is negative, and you need to either look at it as -3 over 2 or as 3 over -2, not -3 over -2. Okay, because what's a negative over a negative? A positive. So this is a +3/2, and I want a negative slope. So from my point, I'm going to go ahead and count down 3 and over 2, which you can put me right there. I'm going to do it again, down 3 and over 2. There's my points. Okay, notice if from the origin, if I'd counted up 3 back 2, I would have landed on the line still. So it doesn't matter which way you count as long as you only make one of those moves negative. Alright, so a little bit of summary here. Direct variation equations are in the form y equals kx, where k is not equal to 0, because if k is equal to 0, what happens to x? That's right. So the graph of y equals kx always passes through the origin, because there's no plus or minus anything. And if the slope is positive if k is greater than 0, because remember k and the slope are really the same thing. So this first one here has a positive slope, this one over here has a negative slope, k would be negative. So we're going to actually get out of graphing equations for just a minute and talk about writing equations. So if you know that y varies directly with x, we can write an equation in the form y equals kx. So suppose y varies directly with x and y equals 9 when x equals negative 3. So this is telling you that y varies directly with x. So I know I can use the equation y equals kx. So the directions here say write a direct variation equation that relates x and y. So if I want to relate x and y, I need to know k. So y equals 9 when x equals negative 3. Here's what you do. Y is 9, k is k, x is negative 3. You need to solve this for k. So let's divide both sides by negative 3. Those cancel. K equals negative 3, because that's what 9 divided by negative 3 is. So my equation is y equals negative 3x. So here's what I did. I plugged in what I knew so that I could find k so that I could write my equation. Now I want to use my equation to find x when y is 15. So I'm going to use this equation. Y is 15. I want to solve for x, so I'm going to divide by negative 3. X equals negative 5. Alright, two more examples. So same thing. Suppose y varies directly with x. It is telling you this is a direct variation. You are to use y equals kx. And y equals 6 when x equals negative 18. Okay, so here's my equation. Y is 6, k is k, x is negative 18. I want to solve this for k because that's what you need to write your equation. And you're leaving these as a fraction, but that can be reduced. That is a negative 1/3. Y equals negative 1/3 x. There's my equation. Then I want to find y when x is negative 2. So I'm going to put a negative 2 in for x. Negative 1/3 times negative 2 is a positive 2/3. There we go. Alright, one more thing to talk about. I'm not going to do any examples on the video for you, but you do need to know d equals rt. Distance varies directly with time. This is really a y equals kx problem, just specifically for distance, rate, and time. So if distance varies directly with time, your rate is your k value, your constant of variation. So make sure you have that written down. Alright, we'll see you in class.